Okay, here are the notes for 5.2.5. Just going to do some applications of quadratic functions and equations. So they actually do show up quite a bit. I think one of the best examples that I can think of, and maybe not quite as fitting right now, but if you or your family still have like DirecTV or Dish, you don't necessarily just stream everything at home, you have one of those dishes on the outside of your house. And if you really go take a look at it, the shape of it, starting from the center, if you were to draw two arcs or curves out from the center, you would actually be in the shape of a parabola. So we're going to go through and see if we can take a look at some different situations and see if we can come up with an equation that models it. So here we go. So we've got a garden that is going to be built up against a wall. So I think some of you guys, especially during these times, I know that around me a lot of people are building gardens now or have been outside of their house. So we want to make sure that we can fence it in. So basically we're going to have a house, but then right next to that house, we're going to have our fenced in yard or garden. So let's see, we can get our house going here. So let's say this is our house. And next to it, we're going to put our garden. So if we want to put our garden, let's say that we've got some pink flowers that we're going to put out there. We have to figure out, and we don't really know what the dimensions are going to be. So I don't know if the flower garden is going to look like that, or if the flower garden is going to be right up against the house like that. Don't really know. What I do know is that it's going to be built next to the house so that I really only need 3 sections for the fence. So I don't have to build the fence right next to the house because I'm just going to use the house as part of the fence. So if I go back to my picture here, I want to make sure that that portion right next to the house does not have any fence there. So the only thing that I'm looking at would be this here and here. I do want to build it in the shape of a rectangle, and my width here. So what I want to try to do is try to figure out exactly what the dimensions are going to be. And I have to make sure also that I obey the fact that I only have 100 feet of fencing. Now I am going to highlight that in pink, same color, because that represents the outside of the fencing itself. So I know that if I take the 2 lengths, so let's call it 2 length, so 2 length plus 1 width, that's going to have to be 100 feet of fencing. Okay. But then I have the next part. I need to enclose 600 square feet. Okay, so 600 square feet. Okay, basically what that means, if I go back to my picture, that means that inside that fencing, so all of this, I have to make sure is 600 square feet. Okay, so that is going to be my area. So let's think about this as my area. Well, we know that the area of a rectangle is length times width, or base times height, however you want to look at it. So I know that length times width is the area, but I have to enclose 600 square feet. Okay. All right, so it looks like I'm going to have to do some work here. And I think I'm going to introduce some variables so I don't have to have this length and width business. So I'm going to go back to my picture, and I think I'm going to let length represent x. And I'm going to let width represent y. So let's see if we can rewrite these equations now. So I've got 2 lengths, so 2x, plus 1 width, 1y. And I want to get 100 out of that. All right, let's go through and do the same thing with the next one. So the length is x times the width is y. And remember, that needs to be 600. Okay, so if we take a look at this, looks like a system of equations to me. Oh, let's see. I want to make this as easy on myself as possible. I think I'm going to take the first equation and I'm going to solve for y. So let's go ahead and take a look at that guy off to the side. So I'll take the first one. And I want to make it, again, as easy on myself as possible. So I'm going to take that perimeter equation, or the fencing equation, and let's solve for y. All right, so minus the 2x to the other side. Those are not like terms, so I'm not going to stack them up. 2x's cancel. Drop the y straight down. Looks like this is going to be 100 minus 2x. Okay, now if I go back to the other equation, the x times y is equal to 600. I'm going to plug in what I just found. So I know that y, so right in that location for y, I'm going to substitute in what I just found. So that's going to be the 100 minus 2x. I'm going to drop down the x and the equal sign and the 600. Okay, here we go. Feel pretty good about this. So what I did was I took two equations, both with x's and y's. So I'll go ahead and box that in purple. So there's my two equations that I created. It's a system of equations because I've got two equations with the exact same variables. So then I figured out which one I thought would be easier to solve for, to be honest with you. And I didn't want to do it with the green equation because I'd have to divide. I looked at the pink equation, decided to solve for y because there'd be no dividing. So again, just trying to make it as easy on myself as possible. Went ahead and substituted them together. All right, let's go ahead and multiply this out. So this is going to give me a 100x minus a 2x squared is equal to 600. Okay, this looks like an equation you and I have been doing. So I think I'm probably going to get equals 0. And just see where to go from there. I also like my x squared to be positive, so I'm going to move everybody to the right-hand side. So I'm going to add the 2x squared to the other side. I'm going to minus the 100x, and the 600 was already there. All right, let's see. Oh, I've got a GCF of 2. Let's take that out. So it's going to give me x squared minus 50x plus 300. All right, well, I could sit here and come up with the numbers. So maybe this is factorable. You could also complete the square. You could also solve with quadratic formula. So at this point, you decide your method. Go ahead and solve for x, pause it, and then come back and check yours against mine. Okay, so I took a look at this, definitely not factorable. And then the big numbers, I decided to do the quadratic formula. So I went through, filled it all in, and it looked like I got x is 43 and some change, and x is 6.97. Now, for this situation, I'm going to go ahead and approximate this to the nearest foot. So let's say that's 43 feet, and then we'll do the next one, and let's say that that's 7 feet. Okay, that represents x, though. So looking back, it looked like x is my length. I still have to find my width. So go back up to the original equations that I put inside the purple box. We still have to figure out what the y is that goes with each one of these. So I think I'm going to use the green equation just because it looks a little less complicated. So let's do x times y is equal to 600. You could have used the other one. It doesn't matter. Now we know what x is, so if we use the first one, which is 43 times y is equal to 600. If we solve for y, if I do 600 divided by 43, it looks like I'm going to get approximately, so let's change that equal sign. Let's do approximately 14. Okay, so I think one of the answers is that we would do 43 feet by 14 feet. So that's one of the things that we could do. Okay, let's do the other one. So I'm going to do same equation, x times y is equal to 600. The other x that we calculated was 7 times y equals 600. Let's go ahead and divide that. And this is going to be an approximation. So if we do 600 divided by 7, that's going to give me 85.7. So let's say approximately 86. Okay, so the other thing that it could be is maybe 7 feet by 86 feet. So she wants to make sure that she uses all of the 100 feet of fencing and that she encloses all of the area. Those are basically her two options here. Okay, moving on. So sometimes arches, so like the St. Louis arch, which is what I have pictured here, are used to model parabolas. That doesn't necessarily mean that it is always the shape of a parabola, but we can use it to model. So if we were to use the 630-foot height, okay, so let's go over to this picture. I know that I want to put a height on it that's 630 feet, so that would be the highest point. So let's find that spot. Oh, it's a little off to the side. So that I would say is 630 feet up to the peak, right there. And then we also know that it is 630 feet wide. All right, so at the base, we know that that's also going to be 630 feet. Okay. So using those, I think I can write the equation, well, what would model this? So I chose to put my coordinate plane the way that I did, so my x and my y axis. So based off of where this is located, I would say this point is at 0, 630. And then if I'm using a parabola to model this, that's 630 width. So I have that entire length here. So all the way across is going to be 630. Well, that is going to have to be split in half just because of how parabolas work with the whole balance part. So let's go ahead and cut that in half. So if I take that 630 and I cut it in half, that's going to give me 315. So that's 315 to the right of the origin, so 315, 0, and 315 to the left of the origin, negative 315, 0. Okay, now we're actually back to stuff that we did earlier this chapter. So I know that I'm going to have some a value. I'm going to take my two x-intercepts. I went through and rewrote them as factors. So if you're not sure where I came up with that, go ahead and refer back to the stuff that we've done previously. And then I have another point, and my other point is 0, 630. So let's put that in. And then let's solve this. So that's going to give me a, so in this case, it's going to be 315 times negative 315. This is huge. So, well, tiny actually, because it's negative. So negative 99,225. Okay, so we're going to divide by that. And I think I'm just going to leave it as that number. So I'm going to get negative. So I know a positive divided by negative is a negative. Doesn't matter if you put the negative sign in the top or the bottom. It's still the same. So that's going to be equal to A. Okay, now we can actually write the equation here. And I think we're just going to leave it in factored form. So let's do negative 630 divided by 99,225 times our x-intercepts, x plus 315 and x minus 315. So just a couple of situations where we can use parabolas to model the behavior of what's going on. Arches are actually pretty common.